One very important concept in the area of probability is the notion of random variables. Okay, random variables. Sometimes you see it denoted as RV. Okay, what is a random variable? It's really a function. A random variable x is a function from the sample space S of an experiment to the set R. Okay, all real numbers. Okay, in other words, x is a function from S to R here. Again, this is not a probability function, so does not have to give a value between 0 and 1. They don't have to add up to 1 or anything like that. This is just a function that we look at every possible outcome from that experiment. We give that outcome some sort of a value. What that value is depending on what it is that we are after. So let's start with a simple example here. So suppose I toss a coin twice. Okay, so a coin, fair coin, is tossed twice. And suppose I'm interested in a random variable that captures the number of heads that appear in the outcome. Okay, so for outcome S, the function, this function S, sorry, it shouldn't be big S here, it should be small s, xs equals the number of heads in S. Okay, so if we look at the coin being tossed twice, and we think about the sample space, it is either head head, head tail, tail head, and tail tail. Okay, so x is a random variable that assigns to each one of these outcomes the number of heads in that. So what this variable does is that for h, it assigns the value 2, and for ht and for th, it assigns the value 1, and for tt, it assigns the value 0. Okay, so the random variable here captures some sort of an event or quantity that we have in mind. Okay, I will show later something about the average case running time of an algorithm. Then the random variable that we are interested in is going to assign to every input the number of steps that the algorithm takes on that input. Okay, now of course we are talking about probability theory, and we are interested not just in the values here, but what is the probability that a random variable assigns a specific value here. Okay, so we are talking about what is the probability, for example, in this case, what is the probability that x equals 0 in this experiment? What is the probability that when we toss a coin twice, the number of heads that we see is 0? The probability of x equals 0 is basically the probability of tt, right? And in this experiment, it's 1/4. What is the probability that x equals 1? It is the probability of tt, plus t. If it is 1, it's the probability of ht, and the probability of th, which is 1/2. And what is the probability that x equals 2? It's the probability of hh, which is 1/4. Okay, so if you look at this, and if you look at the value that every possible value that the random variable can take, let's say x, and p of x equals x, this set of pairs is really a probability distribution. Okay, so this is the probability on the values that a random variable can take. So in the case of this experiment of tossing the coin twice, what I'm saying is that the probability of 0 is 1/4, and the probability of 1 is 1/2, and the probability of 2 is 1/4. Okay, so this is the probability distribution for this random variable that counts the number of times we see heads. Let's look again back at the example of generating these random graphs under the Erdős-Rényi model. And P, N is the number of nodes, P is the probability of adding an edge. And remember the way the experiment worked, we look at every 2 nodes, we toss a coin, a biased coin. With probability P we add heads, and with probability 1 minus P we don't add an edge. And the question is, for example, I can define, so the sample space, remember sample space is the set of all graphs on n nodes. All graphs on n nodes. And I can define the random variable x for G, where G is a graph in S, is the number of edges. The number of edges in G. Okay, so this is for every G in this sample space. Okay, so the first question is that what are the possible values that x, this random variable, can take? Of course, a graph can have 0 edges in it. The graph can have 1 edge. A graph can have 2 edges, and so on. So, and we have done the calculation. What is the maximum number of edges in a graph with n nodes? So x of G takes values in the set 0, 1, 2, all the way to n times n minus 1 over 2. This is the maximum possible value that x of G can take. Okay. Now, question we might ask, what is the probability? Let's say, what is the probability that x of G equals k? Okay, or x equals k. So we are asking, what's the probability that this random variable takes the value k? We have done this already when we asked what's the probability that the graph has k edges in it, and the probability here was that from each one of these pairs of nodes, we need to choose k, where for k of them we put an edge between them, so this will be p to the k, and for the remaining ones they are not connected by an edge. Okay, so this is the probability distribution of this random variable that assigns to every graph, random graph, the number of edges in that graph. Okay, and if you look at this, you should see that if you look at this probability that the p of x equal k, where k goes from 0 to n times n minus 1 over 2, this must add up to 1, okay? Because it's a probability distribution here. That if you look at the sum of the probabilities of graphs having 0 edges, and 1 edge, and 2, and 3, all the way to n times n minus 1 over 2, then the sum of this is 1, okay? So to summarize, a random variable is nothing but a function that assigns a real value, a real number, to every outcome. Now, I say real just to be general, but in many cases, as you are seeing in these 2 examples I showed here, what we really need are some integers, okay? In particular, in these 2 cases here, we needed non-negative integers. But in general, nothing stops us from assigning 0.7 to one outcome, or 0.9 to another outcome, and so on. Okay, so a random variable is a function that assigns a number to an element to every element in the sample space, so to every outcome, and the probability distribution of that random variable is defined by the probability of that random variable taking on any of the possible values. Okay, so when we looked at the experiment of tossing a coin twice, and the random variable denoted the number of heads, the possible values were either 0 heads, or 1 head, or 2 heads. The probability distribution is given by what's the probability x equals 0, probability x equal 1, and the probability of x equal 2. When we talk about the experiment of generating random graphs under the Erdős-Rényi model, and we look at the random variable denoting the number of edges in the graph, then that random variable can take any value between 0 and n times n minus 1 over 2. The probability distribution is given by what's the probability that x equals 0 and the probability that x equal 1 all the way to the probability that x equals n times n minus 1 over 2.